How to use histogram in AI. Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito for you has them all. It's like having a research dream team on demand.
Welcome to The Explainer, where we take big, complex ideas and, just make them simple.
All right, let's start with a little puzzle. Take a look at this. What are we even looking at here? It's really tough to tell, isn't it? All the details seem to be lost, just kind of crushed together there in the shadows.
So how do we fix this? How can we use data to make the invisible, well, visible? Turns out the answer lies in a tool you probably met back in school but might have forgotten. A tool that, as we're about to see, has some serious superpowers hiding in plain sight.
Okay, let's dive right in. How do we reveal that hidden world? Well, we're going to use a surprisingly simple tool, our hero for today, the humble histogram.
So what is a histogram? At its core, it's just a way of sorting and counting things. For a picture, imagine it's counting up every single pixel and tossing it into a bin based on brightness. You've got a bin for the pure blacks, a bin for the pure whites, and a whole bunch of bins for all the grays in between. All right, so let's go back to our mystery image. On the left, yeah, it's a dark, murky mess. But watch this. We apply a trick called histogram equalization and boom, look at the right. Same photo, but now it's bright, it's clear, it's packed with detail. Suddenly, we can see the buildings, the lights, the trees, everything that was just hiding in those shadows. And this is the really cool part, the crucial point. We haven't added any new information. The details were there the whole time. All we did was take the data from that first histogram, where everything was all bunched up, and we stretched it out, spread it across the entire range of brightness, just like you see in that second histogram. And that simple little stretch, that's what makes everything pop. Okay, so that's cool for photos, but this concept of spreading out data to find hidden stuff, it goes way beyond just fixing a dark picture. As we're about to see, you can scale this up for some incredibly high-stakes work, like I'm talking about protecting satellites in orbit. Think about the scale of this problem. In the world of IoT, the Internet of Things, you're not just trying to find details in one picture. You're trying to spot tiny, critical errors, anomalies, in a non-stop, massive flood of data coming from something like a satellite. It's the ultimate digital needle in a haystack. So how do you solve that? Well, researchers took our simple histogram and gave it a major upgrade. They built this system called HCAD. That's for histogram-based categorical anomaly detection. And as you can see, this thing is built to sift through those massive data streams in real time. But here's the twist. This is not your standard flat 2D chart. They came up with a 3D histogram. It asks much smarter questions. It's not just, hey, what state is the sensor in? It's also asking, okay, but how long did it stay in that state? And the real kicker is, and how often does that exact combination of state and duration happen? It's building a super detailed fingerprint of what's normal. And the results? Honestly, they are just staggering. Using real satellite data, the histogram method, HCAD nailed it with a perfect 100% accuracy. Compare that to a much more complex, fancy AI technique that only got 34%. It's just a brilliant example of a simpler, smarter tool absolutely crushing the competition. This success, though, it brings up a huge question. We're in the age of AI, right? Deep learning is everywhere. So does an old-school tool like the histogram even have a place anymore? Well, the answer is pretty fascinating. You see, traditionally, data scientists had to engineer features by hand. It was like following a super precise recipe. The rules were fixed, and that was that. But modern AI is different. It learns what's important all by itself, kind of like a master chef inventing a brand new dish on the fly. It's way more flexible, way more adaptive. So, which one's better? Well, what if you didn't have to choose? This is where it gets really clever. Instead of throwing out the old for the new, researchers figured out a way to plug the histogram's logic directly into a neural network. They call them neural histogram layers. And here is the magic trick. The AI doesn't just use the histogram. It actually learns how to build the perfect histogram for whatever it's looking at. It's constantly adapting the bin sizes, the centers, everything. You can literally see the difference. On the left, that's the old, fixed, kind of blocky way of seeing things. But on the right, that's the AI-powered version. It's adaptive, it's nuanced, and it's pulling out way more useful patterns. It's like upgrading from a hammer to a laser scalpel. And the numbers, they don't lie. Just look at this table. The methods with learned in their names, the ones using these new neural histograms, they consistently smoke their older engineered counterparts. Look at that PMRI dataset. The accuracy jumps from a kind of sad 54% all the way up to almost 90%. That is a game-changing improvement. Okay, but let's be real, no tool is perfect, right? As powerful as the histogram has become, it's not a silver bullet. It has its own kryptonite. So is the histogram always the right tool for the job? The simple answer is a hard no. And honestly, knowing when not to use it is just as important as knowing when to pull it out of your toolbox.
It really comes down to three big challenges. First, it's super sensitive to how you set up those bins we talked about. Get it wrong and you're in trouble. Second, if your data is really skewed, the histogram can totally lie to you. And third, just one single crazy outlier value can squish the whole chart and make it impossible to read. I mean, just think about it. You can take the exact same data, and just by changing the width of your bins, you can make it look completely different. You might accidentally hide the most important pattern, or even worse, you might trick yourself into seeing a pattern that isn't even there. That's how you end up with some really bad conclusions. So when you take a step back and look at the whole picture, the histogram's journey is, well, it's pretty incredible, right? It starts out as this basic chart you probably drew in grade school, and it evolves, step by step, into a critical piece of some of the most advanced AI we have today. I think the big takeaway here is that the most powerful tools aren't always the brand new, shiny ones. Sometimes the biggest breakthroughs come from finding the hidden potential in the tools we thought we already understood. It really makes you wonder, doesn't it? What other simple, everyday tools are just sitting there waiting for us to reinvent them?
And subscribe now for amazing videos just like that. Thanks for watching.